Now that we've mastered basic user input, parsing, and type conversions, it's time to unlock even more powerful tools in C#. We'll dive into mathematical methods, understand how static and value-returning methods work, and see how we can format our output professionally. Let's move forward. The previous example ties together everything we've learned about user input and calculation. We prompt the user to enter a value, use readline, to capture it as a string, then convert it to a double using double.parse. Finally, we square the number with math.pow and display the result. It's a full cycle: input, parsing, computation, and output, very typical in real-world programs. Besides parse, C# provides the convert class, which offers more flexible type conversion methods. Convert dot to double, convert dot to decimal, and convert dot to int32 allow you to safely convert data between types. Convert is more tolerant than parse and works well especially when you're not 100% sure about the input format. Here's how convert works practically. Suppose you have a string 123, convert.toInt32 string value will turn it into the integer 123. But if the string isn't a valid number, it will throw a format exception, just like parse. The convert class is crucial when building resilient input processing applications. C#'s math class is packed with useful methods. Math.floor 88.62 rounds down to the nearest whole number, 88. Math.log4 returns the natural logarithm of 4. Math.max 8713 returns the bigger number, 87. Math.abs minus 88.62 returns the absolute value, 88.62. These methods save time by handling common mathematical operations accurately and efficiently. More mathematical tools. Math.ceiling 88.12 rounds up to 89. Math.cos returns the cosine of an angle in radians. Math.xp2 calculates e raised to the power of 2. Remember, angles passed to trigonometric functions like cos are always in radians, not degrees. Even more math operations. Math.sin 46.3 returns 1 because the number is positive. Math.sin calculates the sine of an angle in radians. Math.scart25 returns the square root, in this case 5. Notice how C# covers basic math but also important scientific functions. And finally, Math.tan gives the tangent of an angle. Math.min 8713 returns the smaller number, 13. Math.pow53 raises 5 to the power of 3, result is 125. Math.round 87.182276, 4, rounds a number to 4 decimal places, giving 87.9823. These methods are extremely handy in any scientific, financial, or engineering software. Static methods belong to the class itself, not to individual objects. You can call them directly using className.methodName. For example, Math.sin 157 calculates the sine of about 90 degrees, without needing to create a math object first. Static methods are like global tools available whenever you need them. The math class is full of static methods. Here's an example. Math.pow basenum exponent raises a number to a power. Basenum is 4. Exponent is 0.5. So the result is the square root of 4, which is 2. Static methods like these make it super easy to perform calculations cleanly and quickly. Besides methods, the math class provides important constants. Math.pi 3, 14, 15, 9, the famous circle ratio. Math.e, Euler's number around 2.7828. Math.tau, 2 times pi, available from C# 6.0 onwards. Math.scarT2, Math.scarT3, Math.log2e, and others. Constants are useful for scientific calculations where precision is critical. Here's a practical use of a constant. We multiply Math.e by 1000 to calculate exponential growth. The result is printed nicely using WriteLine, formatting it to 2 decimal places. Constants like Math.e make your code more accurate and much easier to understand at a glance. Not all static methods return a value. Some are designed simply to perform an action. Here's a print greeting string name method. It outputs a personalized greeting, but it returns no result, so its return type is void. You invoke it simply by passing a name like print greeting Alice. In contrast to void methods, value returning methods do return a result. They use a specific return type, like int, double, or string. They must include a return statement inside their body. Value returning methods are critical for building flexible, reusable, and testable code. Here's an example. Celsius to Fahrenheit, double Celsius, converts temperatures. If you pass 25 degrees Celsius, the method returns 77 degrees Fahrenheit. Small, clear methods like this are the secret to writing clean and maintainable code. Void methods still play a major role too. This display results method displays the total number of square yards, calculates the total cost, outputs both values neatly formatted. Again, no value is returned. The method's purpose is to perform an action. Finally, when displaying results, you want them to look good. C# offers rich format specifiers like N2 for 2 decimal places, C for currency format, P for percentage, X for hexadecimal, E for scientific notation, F3 for fixed point with 3 decimals, and more. Mastering these makes your program outputs professional and readable.